So this is a reduced pressure backflow preventer. This one happens to be an older Watts 009. I've already loosened the screws mostly. I want to kind of explain, this really isn't a tutorial on the 009, it's kind of more on the principles of how this works. So you can look in there, you see a spring that pushes up on this diaphragm, and that diaphragm rides up and down inside there. So I kind of take this apart. I mean, this will help with the 909 as far as what goes wrong with them. There's a spring in there. This you can't really put in backwards because of the notches on it. So that kind of makes it goof proof. Your check valves are in here. They never come out that easy, so we'll take luck over skill any day. Now, these do come apart. You twist that counterclockwise from that, and this assembly will come apart. But we're really going to talk more theory here as far as what do they mean by reduced pressure principle. So this check valve and this whole device is like any other check valve, except it has one here and then another one in here. It kind of, which that's what I'm here to replace today. So you have two check valves, and then you have the reduced pressure area. So the theory is that this check valve, to have water push through it, that's very hard for me to open. So that's around 8 pounds of pressure. So if coming in from your water meter, say for hypothetical reasons we have 100 pounds of pressure right to here, this 100 pounds of pressure pushes down on the diaphragm and keeps that gasket against that seat. So it's pushing down real hard because that 100 pounds is here, pushing down to here. It took 8 pounds to get that spring open, so that means there's only 92 pounds of pressure in here. So there's not enough pressure on it to overcome the pressure on top. And that keeps this, what they call the vent, closed. So when these fail, they dump water out of the bottom. It looks like that. Now, how would we, what's that telling us when that fails? Well, if our check valve riding in here, we have 100 here, but it takes 8 pounds to open this up. Well, if this gasket in there is bad, the pressure on both sides are equal. So now we have 100 here, 100 here, and 100 here. So all the pressure is the same everywhere. And this spring, so really there's no reason for this to move when we have 100 pounds of pressure here, here, and here. But this spring was installed. And so what's that do? So all our pressures are the same here, here, and here. Now we have the force of that spring that opens that up, pushes this diaphragm up. When the diaphragm's pushed up, it allows water to escape out of the bottom. And so when you walk up to a backflow preventer, and here's just a bigger one of the same thing, and it's dripping water out of the bottom, which this one isn't now, your first inclination really is to check that that number one check valve is compromised, letting the water pressure equalize on either side. And here's our inlet, pushing down on that diaphragm. And when we have our 100 pounds here, all of a sudden this zone is 100 pounds. Our water pressure from the inlet side is pushing down on that diaphragm, the 100 pounds. That spring will lift up the diaphragm and allow water to escape. So there are other factors, but when you walk up onto a backflow preventer and you see it dripping water, you really don't even want to waste time to certify it. What you want to do is take it apart and look for debris. So now this is the number 2 check, and you notice I can push it in no problem. This is the 8-pound spring. This is half of that, if not less. So, but a lot of times you'll get debris stuck in between there and then that seat. So it's very easy to change that rubber, or 9 times out of 10 I'll clean them out, put them back together, and they'll work just fine. There's other tricks, but we don't worry about tricks. So that's pretty much that in a nutshell. A different kind of check valve, say like one on the fire system here, you notice doesn't have the drain on it. So it's just a double check, which means it has a check and a check with no reduced pressure zone. So, and this is on a fire system, which a fire system is still hooked to the domestic water underground from the municipality, and it goes up, and it's essentially stagnant, rusty water, but unless there's some sort of, glycol system, it's not a high degree of hazard. So the governing authority allowed just to be a double check. So this area here, there's no diaphragm or anything. This is just open, so you can pull. On this case, you got to pull the number 1 to get the number 2 out, or vice versa. But this is an Ames, good device. And these double checks, they don't have the spring tension that these do, because these have to have that variable to keep this pressed up. Like I was saying, the 100 to 92 to 100. So we have like an 8-pound variable. Your double checks normally are going to only be at around the 2 to 4 pound. And there's a couple reasons. Is you don't want a huge restriction on a fire line when you have a fire. So if it only takes a couple pounds to open it, more water can flow through it faster. So that's the difference between a double check and a reduced pressure backflow preventer. One would be at ASSE 1015, and one would be, which it even says on there, ASSE 1015 double check versus a reduced pressure. So, well, Mr. Boiler kicked on, I guess, telling me to be quiet. I hope that helps.